Next we are going to be talking about questions on chapter 5. Let's see what type of problems we have here. Okay. Okay. What's this question? This is chapter 5, section 1, question 16. Use a finite sum to estimate the average value of f on a given interval by partitioning the interval into 4 subintervals of equal length and evaluating f at the subinterval midpoints. This is our f, 5 over x, and this is the interval. We are going to subdivide it into 4 subintervals. Okay, partition it into 4 subintervals, and we are going to find the average value using that information. Now I'm going to show you a similar question with the solution. Okay, it's a similar question, but the function is different, I think. Let me see. Yeah, the function is, let me see. Yeah, the function is 1 over x instead of 5 over x. Okay, and the interval is 1 to 9 instead of here 2 to 18, I guess, right? 2 to 18. So this is an alternative question, and this is how we solve such a question. F of x is 1 over x here. So we have the interval 1 to 9. We are going to partition 1 to 9 into 4 subintervals. And if 9 minus 1 is 8, 8 over 4 is 2. So each subinterval is of length 2. 1 to 3, 3 to 5, 5 to 7, 7 to 9. And we want to use the midpoints of each interval. The midpoint of this interval is 2, the midpoint is 4, the midpoint is 6, the midpoint is 8. These are the midpoints that we have. Then we find the heights of the approximating rectangles. Our f is 1 over x, f of m1 is 1 over 2, f of m2 is 1 over 4, f of m3 is 1 over 6, f of m4 is 1 over 8. And we know the width of each rectangle is that x is 2. Then what is the area, approximate area under this curve on the interval 1 to 9? Okay, the area is approximately the sum of the areas of the rectangles. 2 times 1 over 2, 4 times 1 over 4, 2 times 1 over 4, 2 times 1 over 6, 2 times 1 over 8, and you get 25 over 12. And how would you find the average value? Average value is the area over the length of the subinterval. Length of the interval, area is 25 over 12, length of the interval is 8, 25 over 96 is the answer. Let's look at the second question. Chapter 5, section 1, chapter 5, section 1, section 2 maybe, section 2, question 8. Which of the following expresses this in sigma notation? There are 6 terms, as you see, 1, 2, 3, 4, 5, 6, and we can just check each one separately. So the first one, A, let's put k is equal to 1. If you put k is equal to 1, this is 0, the first term is 1, that's good. Let's get the first term here, k is equal to 0, the first term is 1, that's good. K is equal to negative 2, let's put it in, negative 2, negative 1, we get negative here. K is equal to negative 2, this is 0, so we get negative 1 as the first term, so C cannot be the answer. So we are going to just focus on A and B. How about the second term? Second term, k is equal to 2. K is equal to 2. 2 minus 1 is 1, negative 5. Second term is negative 5, right. K is equal to 1, negative 1 and 5. Yeah, this matches 2. So first and second terms are okay with the 2. Let's get the third term, which is k is equal to 3. Okay, 1, 2, 3. 3 minus 1 is 2. negative 5 to the second power 25. This matches, that's good. How about the next? Let's check it all. Okay, k is equal to 3 is fine. K is equal to 4. 4 minus 1 is 3. Negative 5 to the third power is, this is true. And the last one, k is equal to, 1, 2, 3, 4, 5, fifth element, which is k is equal to 5. 5 minus 1 is 4. Negative 5 to the 4 is 6, 25. That's right. And k is equal to 6. 6 minus 1 is 5. Negative 5 to the 5 is this. Negative 3, 1, 2, 5. So that's the right answer. But maybe B is also right. Let's check which of the following expresses it says. Okay. We checked the first three, and let's check the fourth one. 0, 1, 2, 3. So for k is equal to 3, this is negative 1, 25, 125. That's right. K is equal to 4. This is 1. 5 to the 4 is 6, 25. That's right. K is equal to 5. This is negative 1. And this is 3025. That's right. So A and B are the answers to this question. Okay. Yeah, we have another example here, but I'm gonna skip that. Okay, next question is chapter 5 section 3. The question is as follows: graph the integrand. This question is chapter 5 section 3, question 17. Graph the integrand. Use area to evaluate the definite integral negative 8 to 8 square root of 64 minus x squared dx. The value of the integral determined by the area under the graph of the integral is, and the answer is 32 pi, and I'm going to tell you how we find it, but I'm going to show it in a separate answer, separate question. Okay, the question is, instead of, okay, what's the integrand in this question? Is square root of 64 minus x squared, but in this alternative question, f of x is square root of 9 minus x squared. The question is the same. We want to find the integral from negative 3 to 3 f of x, this one, square root of 9 minus x squared dx. So we are asked to find this integral actually, but we are going to find it using the area. Okay. First of all, you see that this is a semicircle, right? Semicircle, you know that. And since this is a circle and it's the area underneath the curve, it's the semicircle. Let's find the area of the whole circle and then divide by 2. Pi r squared is the area of the disk, and then take the half. You get 1 over 2 pi r squared is shown here. 1 over 3 pi, but what is r? R is 3, so it's 9 pi over 2, okay, square units. So this negative 3 to 3 square root of 9 minus x squared dx is 9 over 2 pi square units. And you can solve this question similarly, because this is a semicircle as well. You draw, and the radius of the semicircle is 8, okay, and you can easily find pi r squared. R is 8 pi 64 pi over 2, 32 pi is the answer. Very easily found. This question is chapter 5 section 4 number 13. Evaluate the integral, this integral, and I'm going to solve a similar question, but the integrand is going to be just a little bit different, and the limits are going to be different. Okay, instead of 1 minus cosine 2t over 2, we have 1 plus cosine 2t over 2, and the limits are different, pi over 2 to 0, but the idea is the same. You just separate these guys and integrate 1 over 2, you get 1 over 2t antiderivative, and the antiderivative of this is sine 2t over 4, and you're going to evaluate from pi over 2 to 0. You just plug it in. At 0 you have 0 here, at pi over 2 you have pi over 4 here, and pi here, and this is 0, right? This is 0, and negative pi over 4 is the answer. So you can do this similarly for this question too at home. Okay, see whether you're gonna get this negative 5 pi over 4 or not, okay? Alright, and what is next? Chapter 5, section 5, question 19. Evaluate the following integral. They say integral x cube root of 9 minus x squared dx. They are going to use substitution. I'm going to solve a similar question using substitution. It's not exactly the same, but similar. Integral theta fourth root of 1 minus theta squared d theta. We want to find that, but we use what? Substitution. The inside function is u. U is 1 minus theta squared. du is equal to negative 2 theta d theta. We have theta d theta here. Theta d theta is negative 1 over 2 du. Okay, so instead of theta d theta, I put negative 1 over 2 du, and instead of this, I put fourth root of u, okay, and integrate. And this is the same as negative 1 over 2 outside, fourth root, increase the power by 1, divide by it, plus sc. You get this as the answer, right? You have to convert u to theta, and you just put u is equal to 1 minus theta squared at the end. And you can try this one at home to see whether you get this answer or not, okay? Okay, here's another example. Chapter 5, section 6, question 7. Use the substitution formula to evaluate the following integrals, it says. Okay, so you're going to do A and B separately, and you're going to find the answers. The answers are 0 and 27 over 52. But how would you do? Let me solve a similar question for you guys. Okay. So this is, okay, negative 1 to 1, 5r, 4 plus r squared squared dr. Substitution says that u to be 4 plus r squared. Then du is 2r dr. And 1 over 2 du is equal to r dr. And how about the limit points? Whenever r is negative 1, we put r is equal to negative 1 here, we get u as 5. Whenever r is 1, we get u as 5 as well. So this integral is 5 times 5 to 5, 1 over 2 used to negative 2 du, but an integral from 5 to 5 is going to give you 0. So the answer is 0. Okay, and we change the limits now. It's the same question, but the limits are changed. So we just copy the integrand that we got. We just change the endpoints. Whenever r is 0, u is 4. Okay, r is 0, u is 4. Whenever r is 1, u is 5. 4 to 5, this, okay, we integrate and we get 1 over 8 as the answer. So I suggest you to try these two out by yourselves and try to see if you can get these two answers, okay? Okay.